All right, what's up, Gromies? Welcome to AROYA Office Hours, your source for free cannabis cultivation education. I'm your moderator, Keisha. We are on episode 99. What? If you're on the Hangout or checking us live on YouTube or Instagram, drop your question in the chat, and if it gets picked, we will cover it during the show. Good to be back on the Hangout with you guys. How you doing, Seth and Jason?
Pretty good.
Thumbs up. Yes. Okay, let's get right into it. We love this because we've got some visual accompaniment on this question. So Root and Branch wrote in, they're looking for some advice on what's the best pH range for Rockwool. I had it about 5.5, but I think it's potassium deficiency caused by too low pH. And they sent us a picture of their leaves. I don't know if you can pull that one up, guys. But yeah, recently we've done a few pH overviews recently. It's nice to have a visual so we can kind of talk to it based on like that reality of what y'all might be seeing on your. Yeah, what do you guys think when you have it up?
Yeah, so while Jason pulls this up, and I know we both looked at that a little bit earlier this morning. So there's definitely a few things to consider here. We want to be between 5.6 and 5.9 for our incoming feed pH into Rockwool. And part of that's because that Rockwool has, zero natural buffering capacity, essentially. So we're controlling it directly by our input, and we're not dealing with any buffering, which may be, present in some types of cocoa. However, one of the most important things when we look at a picture like this with pH is not just your input pH, but what is your runoff pH looking like? So despite what your input pH is, if you're not, consistently replacing a significant portion of the water in that every day, you're not necessarily, I'll use the F word here, flush, but you're not flushing it back towards like exactly what you put in. A really wasteful way to approach all this when we're talking about having, 3, 5, 6 EC as a baseline in the block would be to feed 100% of block volume every day and completely replace all of the nutrient solution in the block so that we have complete control. Since that's not economical or practical in any way, not only from a cultivator perspective and dollars, but also from a sustainability standpoint, that would be an extreme waste of water. What we want to look at is what is your runoff pH coming out of that block. So if you're feeding at a 5.6 or even a 5.9, that's great. But if over time we see that pH drifting down lower and lower and lower in the runoff, that's a sign that, hey, this plant's taking up enough nutrients that we're not keeping up with its supply. And that's, a little bit where we might see deficiencies. And also that pH drift can occur over time. So by the time you see, some of the symptoms we're seeing in these pictures, the damage is already done. So if that pH is drifted from in the runoff, especially from, let's say, a 5.6, 5.7, putting it at a 5.9 down to a 5.2, by the time we've reached that 5.2, registered it, and then see the symptoms on the plant, it's too late to fix it. So next run, what I would highly recommend doing, especially if you're in Rockwool, is getting one of a number of runoff collection methods in place. So you've got your classic Dutch leach trays. There's raised pots like from the Bucket Company. There's a few others that can easily help you capture your runoff. I would highly recommend tracking that and seeing what is your input pH versus your runoff pH. That's going to tell us if pH is an issue. If our input pH is 5.6 to 5.9, runoff pH is in a reasonable, 5.4 to 5.8 zone based on that, then we're healthy. Just the input pH is probably not your biggest thing. And also, definitely check if you've got a 250-gallon reservoir sitting there all day after you mix nutrients. Go verify that, like, hey, yes, I mixed that up first thing in the morning. I started putting water on maybe 2 hours later or less. Is that pH the same as when I actually mixed up that tank? Because there's a few different reasons we can see a difference between pH in the actual tank and what comes out at the dripper. Time, temperature, and environment being a factor in that. Also water quality.
Yeah, I'm just going to add a few things on here. So I've got the picture up here. Looks like for me, that doesn't look like a potassium related deficiency. And then even more importantly, when we actually look at the availability charts here, this one is specifically, I'm looking at pH nutrient availability for Rockwool. It's actually, the availability is going to be the same for nutrients. The only thing that gets adjusted when we're looking at different types of substrates is what level of pH that these deficiencies, excesses, the availability changes at. And Vice versa from what the question actually asks, potassium is higher in availability when we go down in pH. And so what really is going on here is probably something other than this. And this is an issue that I've run into in a lot of different aspects of my life. You know, if I'm diagnosing a motor, if I'm diagnosing plants, whatever, like I get an idea of, hey, this is probably what I'm encountering. And sometimes it takes me down a pathway that is not as successful as being a little bit more omniscient about thinking all the variables that are going in here. So Seth covered most of what we're trying to evaluate is, all right, are we dealing with a pH issue or are we dealing with a potassium deficiency? Which one have we absolutely verified? Right. If pH is going in at 5.6, then checking the things that he was talking about is probably going to mean that it's not a pH issue. 5.6 for Rockwool is what most manufacturers and what most growers recommend. It's what I recommend for Rockwool. Potassium deficiency, probably not. To me, it doesn't look like it from the photo. And so I would probably take a step back and start to identify, all right, what other things could be going on here? So we need to be taking a look at all the variables we typically talk about here in office hours. And not to cheat, but my easiest answer is always just to send in for leaf tissue analysis. Because if you're worried about a chemical issue, that's going to give you a fairly quick and easy identifier, fairly cheap identifier as far as if it is related to nutrients. There's a likeliness that it could be related to other variables, environmental factors or irrigation styles. So I'd take a step back if I was you.
Yeah, and when it does come to potential deficiencies, right? The disappointing answer is feed more. A lot of times feed at a higher EC and replace those because it's really difficult to effectively supplement a nutrient program. And usually when we see, and actually want to keep that picture up, Jason, usually when we see plant health issues, especially like we always talk about at this point in the industry, we actually do have cannabis specialized nutrients that provide everything you need. So if you do go and get a tissue analysis test and it says, hey, you are low on magnesium, phosphorus, nitrogen, whatever it may be. Well, why is that? Are you not giving it enough? Or do you have a particular water quality situation that causes certain parts of that mix to, fall out much easier and become less plant available? So that's one thing. But based on this picture, there's one really telling thing you can look at to identify a environmental, feed, pH, or EC issue versus an actual plant deficiency. And that's, if we look at this, the area where we're seeing the main effect of the plant health here. So if we look at the space in between the veins, the interveinal space on the leaves, I'm not seeing any spotting. I'm not seeing any light yellow veining. The most place I'm seeing the symptoms is actually the marginal leaf edge. And when we're looking at that marginal leaf edge is the most distal point on any leaf or branch from the actual source of water for the plant, which is the roots. So it takes the most energy to get water from the roots of your plant out to that edge of the leaf. So when there's any inhibition to the water flow from the root to the edge of the leaf, which could be from over drying, too high of EC spikes, bad pH, which may or may not be the issue. We didn't get any runoff info in this one. But when we see that creep in from the edge of the leaf like that, it's not usually a plant nutrition issue. It has a lot more with pH, excessive up and down EC swings where we're constantly changing the osmotic pressure on the plant. So it is constantly trying to have to adjust and can't efficiently uptake water inside of a zone.
Or VPD swings.
And that was the next one. We see this kind of stuff a lot when we go from a really well-built dry room, let's say, to a, my classic example is we put a bunch of systems in place and we've helped people grow, 20 to 50% more biomass. And suddenly they're completely out of dehumidification capacity. They can't keep up at all. So the engineering trend is to add dehumidification and air conditioning capacity to deal with that. But at a certain point, it's easy to over dry your room and not have enough humidity during those first few weeks, especially when we're trying to really ramp up that light intensity. So we see that a lot. If you can't get your VPD below like a 1.0, 1.9 in those first 3 weeks, that's where a lot of growers are having to hit it with, a lot lower light levels to help compensate and not see that marginal leaf edge necrosis and tacoing that we talk about when your leaves are a little dry and a little curled. That's a much less extreme version. So once again, the holistic approach, get those pH runoff or those runoff pH numbers and start tracking it there.
Yeah. And I think I just want to focus a little bit on the foreground here because, as you had mentioned, we don't have any interventional chlorosis. All of the, I wouldn't even necessarily consider this necrosis yet. Most of it's just the loss of any active photosynthesizing cells in the plant itself towards the edges of the plant. But if we look down in the background, we can see some downward clawing on the fresh tips of these plants. And so you're looking at something that is most likely related to what Seth was talking about here.
Yeah, I mean, this is a classic. If I really had to know other incoming information, this is something I see that happens all the time when people flip from, like I said, a really dialed veg room to a less than dialed first 3-week flower room. That first round of leaves that existed in the veg room comes in. They're not adapted to that higher PPFD and higher VPD environment, so those leaves suffer. Most leaves growing after that, we see good, healthy growth with nice, lush foliage. That really might be it, is just hitting it a little too dry, a little too high light intensity, and not matching DLI and other conditions when you move the plants over.
And this reminds me of actually a lot of struggles that I've dealt with clients when, and for me, this is kind of an old school challenge when they thought, hey, transplant is a stress indicator, right? Like the plant's in a new media and we've upped our lighting. Well, hopefully they've upped their lighting. But one of the reasons people don't match their DLI to flowers because they are worried about issues of stress and induction in the plant. And most of the time that comes down to the actual physical movement of the plant from one environment to the other. And it's really means that when we're looking at our parameters in veg, rather than being, touchy-feely about it, let's just take the parameters we can measure and match those when we hit flower. Touchy-feely is great and all for getting an idea of it. But for me, it's hard to feel a 5 or 10% difference in relative humidity, especially if I'm making some other certain changes. If I'm looking at an increased lighting intensity, then I want to make sure that regardless of how I feel in the room, my environmental parameters are check. And it's also vital to use consistent equipment across those rooms as well. So if I'm measuring relative humidity, VPD, a specific way in my veg rooms, I want to do it that same specific way in my flower rooms. And it also brings up a comment we have quite a bit in the past where we're looking at what is the leaf surface VPD. If I'm going from an LED veg room to an HPS flower room, I'm going to have to make some temperature changes or adjustments to really get that environment dialed like I want.
Yeah, I'm glad you touched on that because that's something we're seeing more and more commonly out in the wild, right? Like LED veg rooms and HPS grow rooms, because a lot of facilities are in a stasis of switching over and, hey, you don't have as much veg as grow rooms and you're getting great performance off your HPS as it is. Your inspiration to change might be power consumption, might be technology related moving into the future, but that is a huge reality. Just as an example, when we talk about, typical flowering rooms, I don't know, Jason, just looking around, seeing a 6 to 8 degree difference on leaf surface temp changing only the lighting source is not uncommon. So if you're even if you are attempting to match DLI between an LED and an HPS room, it's really good to go in there and start getting those leaf surface temps and actually making sure that you're not overheating and over drying the actual plant itself. Just keep in mind that everything we do in this entire, controlled environment really focuses on that 1 to 2 millimeters around the leaf surface. At the end of the day, that's what we really have to dial.
Well, let's break it down a little bit, because when we think about a lot of the growers that I work with, they love their HPSs.
Mm-hmm.
I love my HPSs, especially for flower. We're getting a great spectrum to encourage the growth of the plant, to encourage the maturity of the plant, the ripening, and finalize with a good product. Do I think that LEDs are probably getting close to some of the spectrums depending on the LED manufacturer, but there's way more variance. When I go get an HPS bulb, I'm pretty sure that regardless of the manufacturer, that HPS bulb is within a close percentile of what my wavelength, what my spectrum output is from another HPS bulb. And, fixture to fixture, there's no difference. It's all based on the bulb itself. And so when we think about, all right, well, when I'm coming from a LED veg, which is my favorite, I like getting a little bit more blue spectrum when we're in the veg. I like to have that efficiency. I like to be able to have my humidities high, have my temperatures high, and not necessarily worry about temperature fluctuations based on, lights off. Um, when we think about, all right, well, we're going from a LED room that might be 500, 600 micromoles to get us to a pretty decent vegging plant. Well, now if we're 18.6, we're going to 12.12 light cycle. I know I need at least 33% more light, right? So not only are we getting a lot more light intensity, but if we're migrating from LED to an HPS, we got a lot more power. We got just a ton more solar radiation that's hitting the leaf surfaces here. And so, one, that's affecting the plant itself. And two, it's affecting how your HVAC is operating.
Document, like we always say, the holistic
Yes,
picture.
every episode, all 99 of them, for real. Awesome, you guys. Thank you for that. Just to kind of bring this overview home, we did get someone else right in. They're talking about their lower leaves and inner leaves are drying out, brown and crisping up. Didn't know if it's too much of a dryback or too high of EC. So what is the best starting point that you would advise for people when they experience that?
So lower and inner leaves drying back, turning brown, etc. So there's definitely a few things to look at. Just, following with that conversation we just had, your lower and inner leaves, some of them are going to be some of your older leaves on the plant. Now, if any of those inner or lower leaves, especially down to where we typically see the plant start to fork out on those lower branches, if those existed in veg, they actually did grow in a lower PPFD, higher humidity environment, and they're not adapted to life later in the life cycle. So once we hit that 1.3 to 1.6 VPD, let's say peak bulking, and ideally you can keep it tighter than that, but that's a good range. Those particular leaves start to experience, water stress. It's harder to pull water up. And also, just like, I'm pretty pale right now. I've been out of the sun all winter. If I go outside, I'm going to get a sunburn, especially if I don't try to slowly tan. Well, when plants are growing tissue, they're producing an amount of chlorophyll and other pigments that help them deal with the amount of solar radiation that's coming in. So if you have a leaf that's growing in one amount of solar radiation coming down versus one in another, that's actually building tissue to adapt to that level of light. So if I have that lower leaf, and in a lot of plants, the classic example is like the petiole, those first two leaves that pop out of the seed when you sprout it, those always turn brown and die off. They never actually make it to maturity in the plant because those leaves they were formed inside the seed, basically. They're not adapted to anything other than being a sugar source that allows the plant to grow more leaves. So when you see some of those dying off, that's natural. That's also part of why we go in and do a, 42 to 45 day cleanup. That's that hygiene cleanup we talk about. You're going in and pulling out leaves that are maybe big true fan leaves. They grow at the junction between two branches. They're not feeding directly any particular bud. The plant doesn't have a lot of use for them. Plus they're shaded. Plus they're in an environment now that is drier than when they formed. So you're going to see some of those leaves brown and fall off. That is not necessarily a sign of bad plant health. However, if you see that creeping to other leaves, particularly ones that are attached to the base of buds, that's when we start looking at actual plant health issues.
Yeah. And kind of a side effect here is some of the leaves that we're looking at in the picture there, those are going to be stripped off here anyways. So I wouldn't get too caught up unless you start seeing it really creep down into the plant, like some of those lower leaves in the picture.
Yeah. Anytime I've got any kind of plant health symptom, particularly on my leaves and the edges, I go, okay, that sucks. What, I'm going to learn from this, right? I want to look at my factors, see what's going on, see if I can identify it. However, with that particular plant, I know I either messed up or there's a problem somewhere along the line. My next step is to, what do I do after that? If I feel I corrected the problem, if it was pH, what's my confirmation that my actual pH shift that I made worked? Did my strategy worked? And that's where I go, okay, I see this crispy leaf. It sucks. I'm really angry about it. Disappointed in myself as a grower. However, go look for the tiniest, newest growth. So when you see new pistils, new leaves, that's what you want to look for when the plant's developing new tissues, when it actually has an opportunity to establish healthy tissue. There aren't repair mechanisms to make that crispy leaf green again, which is one of the really, really hard things as a cultivator, but also one of the things you need to pay attention to. If that lower leaf, like we saw in the picture, was at transplant or 2 weeks afterward and that thing's doing pretty rough, but just as Jason pointed out, hey, the leaves in the background in that picture looked reasonably green, not super deficient. We actually saw a little downturn tip, which indicates like the presence of plenty of nitrate. So I doubt that person is underfeeding. Those are kind of some things to look at here.
Connecting the dots. Yeah. Amazing. That's such a great overview, guys. Thank you so much. The live questions are coming in fast and furious. I'm going to go ahead and start with our Grow Me Tim, who is on the Hangout with us. He posted, we are growing in a perpetual greenhouse, and we are seeing certain varieties start to herm at day 9 of flower. Light leaks are the first thing we've been looking for, but what other causes could make this happen?
The old perpetual harvest. So, from a manufacturing standpoint, one of my favorite ways to approach this, also one of the most difficult, probably why it's one of my most favorite. I love greenhouses. They're more challenging. Perpetual, even more challenging. So, light leaks, what we talked about, some gas leaks, obviously stressor factors can cause that herming out. On day 9, that's really early. So I'm sorry you're dealing with this, but like, there's something fairly significant that's going to induce herming that early in the flower cycle.
Yeah, I mean, when we're talking about day 9 to basically anything before the end of stretch, typically we're seeing actual pollen sac expression. And part of the problem with that is when we look at cannabis, in humans and most animals, we have an XY expression on sex, right? And cannabis does have XY chromosomes. However, when you throw out the Y with cannabis, I mean, we have growers proving it as we speak. I can take a feminized seed and still produce pollen, right? That's how the feminized seed exists. And that's an XX, not an XY. So you have so many copies of this sex gene that's actually stored on other chromosomes besides just the X and the Y chromosome. In cannabis, a lot of times if we see, that day, 9 is, I'd be worried about growing, some really commercial hemp at that point. But typically that would be an expression of an unstable genetic. And once we start going into the greenhouse, like, how far can you actually alter your environment to accommodate that specific genetic? Again, like I said, day 9, talk to a lot of people that see more in day 10 to 15. With a fully developed pollen sac, that's usually a sign that, hey, I don't have a stable genetic. Another thing to keep in mind is over the last 10,000 years, people have highly selected cannabis to be dioecious. And again, we're proving all the time that it can choose not to be given the right environmental parameters. So really evaluate like, hey, could we run a higher VPD early on? Could we change a lot of factors? But if barring light leaks and barring a gas leak or some other odd environmental factor that's outside of the norms we're talking, if it's isolated to 1 or 2 strains, and these strains do it over and over every single time, unless you alter the environment drastically enough to where it makes one of your other strains herm out, I think it's really worth evaluating whether you need to have that strain in production. And then, I always remind myself that no matter who I'm sourcing genetics from, we really don't have a good written library and good tracking on a lot of this. So, even if you have really good trust with who you got it from, that only goes to that person. You can't logically extend it in a business sense beyond that. And knowing that is out there and that exists, I have to go, okay, well, maybe there's a possibility that no one ever put this particular strain into the environment that I'm growing in. And, maybe this guy growing under HPS in his garage never gets those to herm out. But personally, I've seen a bunch of strains that, talking to the guy who never had it herm out under HPS, and then he switches to LED, suddenly he's got some interesting issues that could be related to spectrum, could be related to heat distribution on the plant. But either way, they selected those genetics to grow under a very certain set of conditions, and now we've just shifted it drastically.
Yeah, and this is, as you said earlier, document. If you can get some documentation from your genetic supplier on how to get this stuff rocking and rolling, it might help you guys with your production cycle as far as looking at perpetual. When we're thinking about perpetual, why it's difficult, we got a little bit less opportunity to modify our schedule. Usually we're based on things have to happen every single day. for plant movement, for facility operations, that type of stuff. And then also, one of my favorite things to do was stack different genetics in the greenhouse differently, right? Like in a good large greenhouse, 5-degree differential front to back would be exceptional.
I was going to say that would be awesome.
Yeah, like probably unheard of. And I just threw that out there as a goal to shoot for. I was really happy to achieve 8-degree difference from the front to the back of the greenhouses. And that was in a 120-foot greenhouses, 120 by 40s. So like, the reality here is, hopefully because you are perpetual, you're moving your younger plants from the front of the greenhouse towards the back, if you will. I guess the way that I say that is dependent on if you're positive or negative or how it's set up. But really what we're thinking about is earlier in the plant life cycle, we want to be warmer than later in the plant life cycle. Ideally trying to optimize photosynthesis, maybe towards the end of the cycle, trying to get some anthocyanin production, make sure that purpling coloring is produced in the plant. So, think about how things are set up in there. And then also think about, all right, are there ways that we can modify, if we have to stick with these genetics, is there ways that we can modify our operations to better improve the consistency or to match the plant life cycle as it moves throughout the facility?
That's a good point, Jason. And just so you know, I do talk to Tim outside of office hours fairly regular. He's an AROYA customer who I really like, but similar latitude to where we are. So just, to follow that up, this time of year, especially as I'm going into the evening or early morning, 5-degree gradient in any greenhouse that I've run up here is factually impossible. Like I might have 30-degree air that I'm bringing into the greenhouse this time of year at 7, 8 a.m. That's a pretty big differential to work on throughout the day when you're saying, hey, we want a 5-degree diff, but if I brought that air in at 30 and then I humidified it and let it heat up across the room with a goal of getting it up to like 77, I probably introduced quite a bit of variability to those plants in the front of the room, especially when I quantify it like, hey, what's the difference between 7, 8 a.m. I'm bringing in 30-degree air, and then by the time it hits 2 p.m. I'm bringing in 65-degree air. There's a lot of variables to deal with there. And I think the thing to really look at is, and this is one awesome thing about greenhouses, because you constantly, at least in the Northwest, you get to screen everything for mold, temperature tolerance, drought resistance, everything in a greenhouse, because our environment's pretty variable up here. But look at that and just try to look at the preponderance of evidence and say, hey, out of everything I've subjected this plant to, has there ever been a solid run? Because I really have encountered that a bunch, where it's like, hey, we've grown this plant 25 times in this greenhouse. My buddy's grown it in his greenhouse, and this thing is just known to herm. Okay, how much can you adjust your production process to actually accommodate that plant, and knowing that it's putting the rest of that room in risk of developing seeds, especially in your perpetual harvest situation.
And I love that you bring that up, because it's so many greenhouses that I work with off the bat. Like most of our clients, most of the people I deal with are indoor. Like greenhouses for me, that's where I came from. That's where I love, because I do quite a bit of control automation programming, that type of stuff. How do we combat some drastic environments to optimize these plants? Indoor, yeah, we get to optimize them way easier, way faster. We get to compare run to run. In a greenhouse, a lot of times we actually have to compare like season to season. We have to break these chunks out and view larger, rather than a 3-month cycle on flower. We got to look at, all right, how did this flower last year? A little bit more similar to traditional ag, where we're on a much longer time frame. And the really fun part is, if we break down the data, we get an understanding of why were those seasons slightly different, right? If we absolutely master the greenhouse, it's going to be just like indoor, where we can go cycle to cycle to cycle. The reality of that, I've never been to a greenhouse that can do that perfectly yet. I did want to mention with those, March days, those April days into the fall, I like to slowly open my blackout, get my lights turned on so I can get some heat consistent across the greenhouse. And if I have a gable vent, I'll optimize that rather than the pad vent. And that's what's going to help distribute some of that cold air as it's coming in at 30 degrees, 40 degrees across the greenhouse, rather than dropping it right on the front plants. spray it across the gable of that greenhouse and let it drop in by itself because of cooling and warm up over those lights.
Yeah, and just following that up, that is one really important thing to consider with the greenhouses, and that even sometimes will tie into your company's marketing. I know in my experience, there were certain strains that if you asked me to grow again in the shoulder seasons, spring and fall, I would just say no. Like, hey guys, let's not grow this strain between February and May. Like, we just won't plant it then, and we won't plant it between October and December. Like, why? Well, our greenhouse has some limitations that we don't have the capacity to overcome without massive reinvestment. And we're not going to make that reinvestment for this one strain. So we can look at things like a limited release program and say, hey, yes, dispensary / distributor, we can't supply you with a consistent line of this product, but we can repitch it to you as, hey, this is limited availability, and we only produce this in certain months of the year. That's definitely a strategy that, comes out over time in dealing with what you have to work with, where you're at. And it's, even if we get out of controlled environment ag, that's how greater ag works, right? Like different parts of the year, we get our raspberries from Oregon, California, different parts over to the Great Lakes, Ontario. But as it gets colder in the winter here in the Northern Hemisphere, that production shifts south, right? The raspberries still keep coming, but everyone farther to the south of us optimizes their crops based on, hey, we're getting to a cooler season where we can actually produce berries at a much more efficient rate. And that works with our distribution systems. We get those berries to the people that can't grow those berries right now. So there's a lot of options there in figuring out, like, how can you approach this not only from a production standpoint, but, bringing in the rest of the company and saying, here's our production reality. These are, difficult bumps we got to get over, but they're not necessarily total roadblocks. We just need to figure out how we're going to handle this, especially if we feel like this particular strain is so important.
Great considerations for people dealing with a perpetual harvest in a greenhouse. Tim, we appreciate your question. Thank you so much for that. All right, our next one, we have another visual example. We got a question from Santa Buzz. They're looking for you guys' insights into some leaf damage that they're seeing. Able to pull that up since that
I'll bring it up right now.
All right, what do you guys think?
Well, we're looking at obviously much more developed plants than we were in the last picture, but we're looking at a fairly similar kind of situation. So we've got a little bit of pale going on interveinally, which it looks a little early to be wanting to see that, but I don't see this happening on absolutely every single leaf. A little bit to an extent. What we're probably looking at is potentially some pretty deep drybacks and pH shift. You zooming in on there.
Oh, I'm just looking at some of our background leaves clawing. I mean, one of the difficulties here is like when leaves start to dry up on the tips like this, they go upward. That's actually the opposite of a lot of times what the deficiency or excess is going to show. And like a lot of times we see that. I like to call it clawing because it looks like it's drooping down over the edge and starts to tuck in a little bit. So rather than a taco, it's a claw, and that's, like it says, when we already see it dried up like this, for me, again, I'm looking at environmental factors. If I do have a really good indicator of its nutrient, or I just want to do my typical diligence, I'm going to go in for a leaf tissue analysis. Sorry, I keep saying it. It's like $20 a time, and compared to what it costs in a run, it's like, all right, I'm going to do that 5 times a run pretty easy on just a strain identification, because all our strains are eating differently. So how do I optimize how I'm feeding them to make the best of it? But I'm probably getting a lot deeper than we should answer here.
Yeah, and this is an example of where we do have a small picture for part of the canopy, and one helpful clue is like, what is the distribution of that in the rest of the strain in that room? So if I look at this bench, I'm seeing some plants starting to get a little concerning, but what I would probably do is take a spot checker out like the Solicer Pro Check, go start checking individual plants right before I actually apply irrigation in the morning to see how far some of those are drying back. So If I had a bench and say this leaf was on, 10% of plants or 20% of plants, I'd want to go in, get my spot check right before everything hydrates in the morning, because, hey, even if I have AROYA, I may not have a sensor plugged into the plant that's looking like it has an issue, right? So I'm going to go get as much data as I can off of that plant in time series throughout the day. And lo and behold, in this case, looking at the few other plants I see around, I would expect the plants that have the most leaf damage right there to probably be expressing the deepest drybacks and potentially be the bigger plants on the table. This is a classic example of what we see when you repeatedly over time push a plant back too far in the dryback. And there's two different things you can hit. One is temporary wilting point, which we don't see a whole lot in outside of irrigation failures, like you have a plugged emitter. We don't typically see a whole lot of actual water stress. But what does happen when we're running some of these higher ECs is when we push that point, our actual temporary wilting point, when the plant undergoes water stress due to lack of water availability, is actually much lower than the damage point, in which we see the ECs start to spike up and that osmotic pressure cause damage to the plant. There are two different actions that can damage the plant, and it's important to differentiate between the two. And that's why, a lot of times we talk about our drybacks going to 20, 25% in, let's say, cocoa. If you have those outlier plants that are, 1.3, 1.4x the average on the bench, this is the kind of expression you'll see when everything else looks healthy. You're giving everything the same amount of water, but that monster plant is just dipping down to 15% every day, where everything else is hitting 20 or 21.
Yeah, I mean, and that brings up probably one of my most favorite things to talk about, and that is, how do we apply population statistics to how we're operating a facility? And if we do have these very significant issue on 1 or 20 plants of 1,000, is that actually representing something that we are doing as an operational parameter, or is it something that's happening throughout the environment or through the irrigation? So plugged emitters, like, so many times in the past, and even recently, I was down in California on a massive site, and it was like one of the first things is pull out the emitter and blow it out, and it was like, all right, we found the problem with that one. It's as simple as that. We don't have to get too crazy with what they're doing, and if they change something that they were doing, it's actually going to be a detriment to the rest of the plants. So identifying, all right, well, how big of an issue is this? Is it specific to a zone? Is it specific to an area in the facility? Is it specific to a strain? How do we group all of the identifiers together and try to see, well, is this something that is an offset of a lack of maintenance? Is it an issue because of a specific strain that we're trying to try out? And rather than going in and making modifications to some of the things that we're even recommending that might be the problem, it's like, well, we're looking at a tiny snippet of this. If I'm looking at, say, a pretty small grow room of 500 plants in here, what do we have, like a quarter of a plant that we're looking at to help diagnose this issue? Like, yeah, I mean, that's a little bit of a challenge. And some of the cool things in the industries are looking at how do we better document this information? Like, how do we use security cams to identify bugs? How do we use security cams and tie them into a data system so that we can, log this information in a timeline together, so it's easier to identify? I think this is probably one of the reasons that I'm really still doing this type of work, is because of how much energy I put into consolidating all of our interpretations of plant responses. A lot of my data came from working in greenhouses for traditional crops. A lot of what I did came from my understanding of electronics and the technology industry. And for me, the fun part was, how do we all build this into the big picture so we can make the right decision? All right. There's a lot of decisions we can make, and 90% of them are wrong.
Yeah, I think that my favorite example is IPM. So once you make the jump from, your couple light setup, and plenty of people argue this with me, but even up to 20 lights, whatever, in your small facility, pest management enters the realm, right? And we say management, not pest eradication. So any problem we're looking at, whether it's pests, nutrient deficiencies, pH swings, any compromise in our system, we always have to weigh that against, what if I did nothing? So in this case, if, and this is just a far-flung example, hopefully the person that sent this to us, like we do have some impactful things that can help them out. But sometimes if you just see, 2% of your plant population exhibiting this, your action for doing nothing now that those plants are actually in the flower room is more profitable than reducing your yield on the 98% of the rest of your plants that are performing just fine. And then at that point, you want to look back and say, okay, well, what is the factor? In this case, like I said before, I would suspect that this plant might be a little bigger, might be uptaking a little bit more water than some of the plants around it. And if that's the case, that inconsistency comes into the picture all the way back at potentially when they cut the clone from the mother and even when they were growing that mom. So at that point, what can my decisions in this flower room actually do to change that? It turns out nothing, other than giving that plant its own valve. So you can water it super precisely, which we're not all about to go put, 1,000 valves in a room to water each plant very specifically. So realistically, hey, sometimes I've got to deal with some of these problems and just build it into my business plan that I will. And also, this is going to sound negative, but you will never hit 100% efficiency. That's not just plant growth. That's everywhere across industry. So I think accepting some of that and then aligning your business strategies with not necessarily the worst possible outcome, but never the best possible outcome. And understanding that even compared to like the alcohol industry, we have a fairly long and complicated production process in cannabis with a lot of points to fail and ruin the end product. So as long as you can holistically get your bases covered, you can start to make some of those process refinements. And then, just don't get too caught up in your head. You're going to see some of this stuff. Like even if you are doing everything perfect, you're going to see some semiclonal mutations. You're going to see some weird things that plants do that eventually will teach you that you can never make a business plan around 100% plant performance. That's just a reality.
Yeah, I love that you said that, because when I look at this picture, I zoomed in a few times there, if you didn't notice, and I think about, all right, if this is a 9-week strain, I'm probably into week 5 up to middle of week 6. And I don't see any response in the pedestals that are dictating that I'm going to have a flower issue based on what I'm seeing in these leaves. And so when I want to think about that is, all right, am I checking off all of the rest of my procedures? Have I done a good job researching that my processes are going to optimize what I'm doing as a business? And I guess, again, when we think about at the full size of an operation, is it worth your time to investigate how much of a problem this is, right? Like, is this problem, am I still hitting 90 grams per square foot indoor on this? Then like, let's ignore it. Let's move on. And if I'm not, then let's go back and take the steps to ensure that I'm hitting consistency. That's like number one. Probably some people would switch out SOPs for consistency, but they go hand in hand, right? And so if one's playing into the other, then go back and take a step on that and see, all right, well, if everything that I'm doing to these plants is right, then how come I'm too worried about this in the facility?
Amazing advice for cultivators and for life. Dropping some knowledge today. Santa Buds, thank you so much for sharing your photo. We really appreciate the visual. All right, we're going to keep it going. We've run it at the hour, and I've got an announcement towards the end, so we got to leave room for that. But we're going to move on to this question from Iron Armor. It seems to fit within these topics. When looking at a plant, what are some morphological characteristics you might see when pushing a plant too generative or too vegetative in flowering?
I love it. It's good to see Iron Armor still on here. He's been posting questions forever, and just a great dude. If you ever get the chance,
yes.
if you get the chance to meet him, hit Southern California and go see the guy. So too vegetative, like probably super easy to dictate. Yeah, we're gonna be blowing out stems. Our node spacing is going to be 3 inches, 4 inches, 5 inches. And it is genetic dependent, right? We could be too vegetative for a vegetative leaning plant, and then we're just going to have like an outdoor, like a massive stretchy plant, we're not going to get nearly the type of controllability that we want out of it. And then even if you have a more middle of the road, we might be too vegetative and just not get quite as much lateral expansion as we want. And this is really, really important when we think about the facility constraints of 2 or 3 tier grow rooms. I was recently in a 3-tier, and like they were limited at about 34 inches of plant height. And so it's like, one, we have to be fairly genetically specific, because even when we're pushing some of these more vegetative type of plants, like I always talk about Blue Dream. It's like one of my favorites to smoke, and it's one of the iconically stretchiest plants out there right now. Well, ever. And so
it produces, that's what it does.
It does.
It gets big.
Like, and even when we push it generatively, it's still going to get big.
Yeah. But 6 versus like 10 feet of a 2-gallon pot. That's the difference there.
I love 6-foot plants. Like,
no one likes 10-foot plants though.
No, like, 5 to 6 footer is where I'm going to optimize how much yield I can get off of it, and optimize how little of inputs that I have for it. Right. But when we get to some facility constraints, like 2 or 3 tier rooms, we want to be running probably more generatively. So identifiers of pushing morphologically. So like how does it represent itself morphologically? Node spacing, plant height, those are the ones that I look at mostly. We got some more detailed parameters that are harder to identify. When you think about leaf area index, how much my pruning percentage on this plant happens. Those are some other identifiers as far as, all right, well, maybe I give this thing too many irrigations over the course. Maybe I didn't have a big enough daytime, nighttime differential early in this plant life cycle to encourage it's hormonal change. So when we think of, like, I kind of think of it as a process, right? So when we talk about crop steering is what we're applying to these plants. Then we have a physiological response. And that means, like, chemically, internally, how is this plant responding to some changes in nutrient levels, irrigation durations, timeframes, frequencies, and environmental factors. My VPT is higher, lower? Are my lights where we want to be to reduce some of the apical dominance going on in this plant? So when we got to kind of focus on, all right, that's step 2 is physiological. And that's probably where we hit on most in this show, is trying to identify how does the plant respond to what we're doing to it. And so I'm glad this is a morphological question. And so, to answer your iron armor here, like, when we think about the ideal shape of the plant, it comes down to, well, what are our facility constraints, right? Like, if I could grow a 6-foot Mac 1, I'd do it.
Yeah, that's a great point though, but you'd push it, fairly generatively, knowing Mac 1, because the opposite end of that, like one of the things we're looking for, Mac 1's a great example. You go too generatively, you get these tight buds.
I'd push it vegetative.
Yeah. But like Mac 1's a great example, because, we're talking about over vegging, essentially over bulking. On the opposite end, we can get a plant that's got, Mac 1. I love that example too, because it likes to grow big buds. But if I push it too generously,
it's like a bunch of gobstoppers on the plant.
Well, and I might actually be hitting a point where I'm starting to induce mold, because I've got a bud that's so tight in a genetic that's fairly mold susceptible that, like, hey, I actually got to be aware of that. Like, if I grow this nug too tight, even if it doesn't get huge, I might be risking mold, because again, it doesn't have any natural resistance to it necessarily. And I've produced a bud structure that's too tight to get adequate airflow in to keep a reasonable humidity level inside, but like in the interplant spaces inside the bud. Right. So typically, from what I've seen when we're looking at, responses to too much veg, just like Jason was talking, we're seeing excessive stretch in the plant. Nowhere are you going to see it more than in a multi-tiered setup. When you're hitting it too many times, you've got a small media. I mean, a great example would be trying to grow in, like, let's say a 4x4x4 Rockwool with high density under, my max height is 3 foot. Well, if I flip those plants too big and all I have to do is water it all day to keep them wet, I'm probably going to start to reach up into the lights and do a bad job. But stretch out buds, one of the other things we see with bulking responses, continued stretch. So if you have a fairly, non-determinate plant and you flip it over into too much bulking a little bit too early, a lot of times we'll see those buds actually start to separate and some weird bud formation. To put it bluntly, if your weed looks like hemp, that might be one of the factors there. If you go back and say, hey, we've watered this thing 16 times a day for the last 6 weeks, and that's all we've been doing, that's an egregious example. And then at the other end, we can push something so generatively, like my classic example is getting into commercial cannabis production. We started growing in 3-gallon pots. Hey, we flipped plants at 3 feet tall, and we grew plants that were 4.5 to 5 feet tall. And man, it was some great weed, but the yield sucked. So that might be, one of the signs that you're pushing it too generatively in your situation. And then you got to kind of modify that and say, okay, what are my goals? For me, I would have loved to grown in 3-gallon pots and slam them all together and produce this amazing weed super easy. All I got to do is water it once a day. That's pretty easy to deal with. However, moving all those pots really sucks. People don't stay around if they're going to have to move those heavy pots all the time. Our yield is not what it could be. And then as a result of those two things, the business isn't making money. And unfortunately, at the end of the day, we got to take all those factors into account. And we can use science to like bridge that gap between the extreme of being, really high labor, very wasteful, and also finding the quality balance we want in there. And you see the same thing in every other kind of craft industry, across the table, whether it's, obviously alcohol is like the easiest one for us to reference as another recreational drug. Like, hey, we see people producing all kinds of different things, but at the end of the day, they all have to find a business model that balances production versus quality. And can there be success in producing absolute quality? Absolutely. Jason and I work with plenty of growers who that's their game, is to produce the best possible weed that they can for their market and maintain their price. The other side of that is they adjust their business model around that, including their inputs, their labor, and everything else to make that a possibility.
Yeah. When I think about why is it important to think about this stuff, it comes down to some of that information. All right, do we have any growth parameters coming from our genetic supplier, right? Do we know anything about this? So first round, we got to do a really good job documenting, because we don't know how to treat the plant as far as, how long do we want to do generative stacking? Like, how long do we want to keep this plant from stretching? Do we have any special considerations to optimize what's going out of it? And, after the first run, we can kind of say, all right, well, this one was growing 2 feet into the lights. Let's do a little bit different things. And the next one, for most of us, will actually go a little too far on how we modify it, especially if we had a drastic parameter from the plant. And then it's like round 3 where we really get to start saying we're optimizing how this strain is growing. Now, if you can get some data from your nursery, it says this is what we experienced. Now you're 2-3 growth cycles ahead of making any of those mistakes. Yeah, every once in a while something crazy comes out of it, but generally, when we're speaking, like every time we grow it, we get a little bit better, as long as everyone involved is diligent and doing some documentation.
Yeah, and I think when you're looking at how you're planning your business for the next year, being realistic. So if you've been in the cannabis game for a while, there's 1,000 different strains and cuts out there. For every 1,000 strains, you've got 5,000 different cuts you could get. Not of each one, but if we quantified it all up, right? So when you look at the totality of the market and what's going on, you say, hey, I want to do the best networking I can, make the best friends I can to get access to the best genetics. However, knowing that the people I'm sourcing them from aren't going to grow in the exact same conditions that I do, knowing that they have a certain amount of throughput they need to do to get the goal, to reach the goals that they're going to reach. What am I going to do as a producer? So if I get burned every once in a while on getting a genetic that doesn't work in my facility, is it to my interest to be upset? Yeah, kind of. But after it happens 5 times, it's more in your interest to go, hey, maybe there's a percentage of things that I take in that are going to work versus don't work. So maybe I need to establish, recognize that, hey, in my market, name a state or wherever, like I need to crank out 5 new strains a year on my brand. Okay, that might require me buying like 10 to 20 different strains to try to run through and do a little R&D and see what actually works and what I can make money on in my market. And I think one of the worst parts about that is you might go spend $500, you might spend 5,000, you might spend 10 grand on a cut to just have it fail in your greenhouse, or go throw it back to the Blue Dream. I've personally thrown hundreds of pounds of Blue Dream into compost piles because guess what? The market got flooded and we couldn't sell it. Is that the weed's fault?
Stupid
No.
market.
Was that my fault? No. It was great weed, but that's the reality. So I think, some of the more successful, especially in the boutique and mid-sized space, some of these bigger companies can deal with some of these costs a little easier because they have more capital flowing through. But some of the best approaches I've seen in the mid-sized space is say, hey, as a company, what kind of investment do we want to make in our genetics every year and staying on top of this game? Okay, if that investment's $100,000, that's going to give me, with the suppliers that I'm working with, the breeders, that's going to give me a certain number of strains I get to run in R&D and play with every year. And I'm just going to set that budget aside and accept that that's a reality, right? If I can take that budget and say, hey, this is my play budget on genetics, I'm not going to stress when I did pay $5,000 for one and it doesn't work out. Instead, I'm just going to go probably talk to that breeder or whoever I got it from and say, hey man, what's going on? What am I doing wrong? Rather than having this idea that, hey, I paid $5,000 or $10,000 for this cut and I have to put it into production. That's not really a productive mindset. And, another little tip for especially mid-sized producers is looking at your advising budget and saying, hey, there's interest in me as a business owner to stay up to date in the market. And that means I might have to pay a little money to go out and talk to various consultants and people in the industry. And you know what? Your best bet on that is to diversify a little bit. You don't need to pick your guru necessarily. Sometimes you need to talk to 20 gurus and see, okay, what are these 20 people saying that seems to be in common? Like I talked to 20 people that were successful. They gave me a lot of different answers, but for my money, I at least got, out of the 40 questions I asked these 20 people, 6 of the same answer. And that has a lot of value in it.
I had a pretty unique experience this week. I was talking to a client that they grow 2 strains in their facility. I never experienced this in my life. Like usually a dozen is like, that's pretty cool. Like we're only working with a dozen that we got to figure out. And so these guys were contracted for the next year to optimize this strain. Super great conversation because this cultivator was 100% focused on how do we make this strain grow as best as possible, right? So many of these conversations that we have on here are probably a lot more applicable to most of the cultivators out there, where it's like, well, half the strains I don't really even want to grow, but that's what our market demand needs. Mm-hmm. This is what our business has to do to stay possible. And some of those growers are fortunate enough to have, I got a facility with a little over 60 rooms. Great way to, make sure that they're optimizing per strain, starting to really diversify their company, optimize as many strains as they can. And then there's the multi-crop sites. Always a huge challenge for the cultivators because now we're so limited by, how do we make this plant kind of grow like a mutual fund? All right. We got 8 strains in a room. Let's try and make the best decision for all of them at once. Not an easy job.
Oh my God, you guys, thank you so much for that amazing information. I want to we're going a little long today, but I did want to share some shout outs. John Wayne, post big up from Now Legal Germany. I love your content and saw all office hours, but never made it to live. I grow for almost 30 years now, but nothing ups my game than the crop steering knowledge here. We appreciate you, John. We got a post here. Love the dedication to hard data in this field. Too much bro science. We are all about the science around here. And then Marlon wants you to know that's a very nice hat, Seth. So with that, we're going to go ahead and wrap it up, but not before I make this announcement and put it in the chat as well. The countdown to Office Hours 100th episode has begun, and we're celebrating with all the Gromies. Head over to Instagram, drop your best cultivation and crop steering question in the comments of the post I just dropped in the chat. And if it gets picked, and covered by Jason and Seth during our next session, which is our 100th episode, you're going to be automatically entered to win an AROYA Go. So you guys are already, the Grummies are already on it with these wonderful questions. Give us your very best one so the guys can cover it. You might win an AROYA Go. Anything else you guys want to say before we wrap up?
Have a great day.
We missed you last week, Keisha. This one was way smoother, I felt like. Jason did well reading the questions, but I think we're always appreciative to have someone moderate for us. That's great.
That means a lot. Thank you. I thought y'all did well, but I have to say, I do enjoy wearing the moderator hat. Feels good. I appreciate you guys. Thank you, Jason, Seth, and our producer, Chris, for another great session. Thanks to all of you for joining us for this week's AROYA Office Hours. If you want to learn more about AROYA, book a demo at aroya.io, and our team will show you the ins and outs of the ultimate cannabis cultivation platform. Crop steering and cultivation questions you want us to cover, we want to hear from you. Drop them anytime in the AROYA app. Email us at sales@aroya.io. Send us a DM. We're on Instagram, Facebook, LinkedIn. We want to hear from you. And if you are a fan of the pod, be sure to subscribe to our YouTube channel so you never miss an episode. All 99 of them. Look out. See you at the next session, number 100. Thanks, everybody.